good morning. Today is Sunday. We are October the 11th. For those Canadians who will be joining us a little bit later today, happy Thanksgiving. Today's topic is, of course, on the important new industry called vertical urban farming. Vertical urban farming has been touted as the newest industry that could possibly disrupt traditional agriculture and farming. What is it? Well, it's the ability to grow crops indoors without sun, without soil, and with rather advanced technologies. And one of the technology companies that is joining us today is Surna. And our special guest today, of course, is Brandy Keene. She's the co-founder and the senior technical advisor of Surna. Surna has been working with our company now since 2018 to put in vertical urban farm rolling racks in traditional warehouses like the one that you can see right behind me. In that facility, and like others that we're designing, we have racks that will stack what we call habitats, which are 10 feet by 5 feet by 6 feet, into rows, into racks, into blocks that make most use of these warehouses. Now, part of the reason for vertical farming's traction, of course, is we are in a pandemic world, and supply chains, including food supply chains, are beginning to break. But we're also starting to see a high rise of food security issues, in which case urban settings and even remote communities are demanding, if not working hard, to put in solutions to cultivate their own food close to where they need it. In other words, grow what you know, what you want, next to where you plan to put it onto the table. So Brandy, with the experience that you've had based in the United States, of course, what are you seeing with regards to the increase in demand on your technology? And then we will dive right in what you're doing. So give us your thoughts. What does the pandemic world look like for you with regards to indoor cultivation? Go ahead.
Thanks for having me, Chris. It's a pleasure to join you guys today, and thanks for listening in. It was interesting because obviously, there was a shortage of capital available, really in any investment when the pandemic first hit, and it was really just kind of the insecurity of not really knowing what was happening, right? And but we also, I think everyone got just a very small taste of what food insecurity might look like in a climate change world, which has been really interesting. We've certainly seen a lot more emphasis on folks kind of exploring the idea of vertical farming as it relates to food production, and then we've seen capital certainly loosen up for other infrastructure since then.
Yeah, absolutely, and we've seen some rather large names wade into the space as well. Last year, we had Elon Musk brother sink in quite a number of dollars, as reported on CNN. These projects or these companies are raising north of $100 million to do international projects, which is really quite amazing, at a time where capital being found for indoor cultivation of cannabis had become very hard to come by. So we have seen, from certainly our position, our point of view, even a rise in the number of companies that are going public solely on the grounds that they're able to grow indoors and in vertical. Now, growing indoors vertical, though, is non-intuitive. Having come from a farm background myself, learning how to cultivate in northern Canada, where you have maybe a full growing season of 4 months, you have to get it right each and every time, or you're not going to feed the family for the year. So learning everything you had to with regards to soil and nutrient, what you had to find with regards to location of plot of land to get the best sunlight, temperature, humidity, pH, EC in the soil, etc., was a challenge on a good day. Now we're indoors. We've got the problem of humidity. We've got problems of temperature control. How do we repeat the batch? And Surna, as I said, is from our point of view, one of the market leaders in the space, what we call best in class in managing it. You've had a lot of experience dealing with cannabis, which is a leafy green that aspires a lot of water into these enclosed envelopes. Can you just walk us through, you've come up with a unique solution. How do you manage that solution? Go ahead.
Sure. And, to your point, I think in a lot of ways, cannabis really kind of forms, what food production may look like, down the road, right? And you're right, cannabis in particular is a very water hungry plant. And so when we are looking at how to manage the environment in indoor cultivation, that transpiration of moisture is our primary challenge. Essentially, it's water in, water out, right? Every drop of water that a plant uptakes is a drop of water or a grain of moisture that is then rejected through the leaf. And that is, think of water not as being consumed by a plant, but as being a delivery mechanism for nutrient, right? You want to force that transpiration in order to ensure that that plant, whatever it is able to continuously uptake nutrient. And frankly, doing the calculations for cooling, although lighting is energy intensive and does produce a substantial amount of heat, that's still a pretty straightforward calculation to do. It's 1 watt is 3.41 BTUs, and it's not exceptionally difficult. Where it becomes difficult is doing the calculations to ensure that your dehumidification is accurate, right? And the dehumidification component is every bit as energy intensive as the cooling component, and in some cases even more, and exceptionally complicated because you generally have both day and night conditions, and you have varying degrees of moisture uptake from day 1 of flower to day 50 of flower, depending on what you're cultivating. And so you have to deal with varying degrees of moisture at varying conditions. And why that gets complicated is because as the conditions change and as the volume of water present in the space changes, so does the dehumidification output of the equipment that you're using to dehumidify, right? And so there are a number of ways that you can manage the climate in a vertical cultivation facility or in an indoor controlled environment facility. The trick is really in identifying which one is most appropriate for the specific application, right? Because not every application is the same. Some folks are cultivating in very small controlled environments, and some folks are operating in larger environments. Some folks really focus on energy efficiency, which is a huge focus of ours. Some folks are maybe a little less concerned about that and are more concerned about those costs. So it's our job to really balance the goals of the cultivator against the budget, against what they're trying to accomplish. And so through that, and in our, almost 15 years in cultivation, we've identified, the 5 or 6 really best technologies that are out there. We've developed some of our own, and some we do in partnership with other manufacturers in the industry. And we ensure that the mechanical design meets every need of the cultivator, and then we implement those technologies for the client to make sure that we're kind of managing it from concept to startup.
Yeah, absolutely. And from our experience, Brandy, it has been a very good one with your company. Being able to engineer custom solutions based on experience, not just technical knowledge or training, is invaluable. It's the old adage of in theory, there's nothing difference between theory and practice, but in practice there is, and you've had a lot of practice, so that's helped a lot, right? But you also, aside from designing those systems, we do have controls. We also have biosecurity, which I'd like you to just chat about a little bit, because again, we get things indoors, and we'll talk about our experience here. The facility behind me now is here at our head office in Panama, right in the middle of the jungle. So we'll talk about our experiences in indoor grow. But you also deal with odor. So can you walk us through a little bit about your controls for biosecurity, of course, in measuring and monitoring, and what are you doing for odor control? Go ahead.
Sure. Well, and I'm glad that you bring those things up, because when you think of mechanical or HVAC design or climate control, you really think of heating, cooling, dehumidification. application, but in indoor cultivation facilities, that biosecurity component and that odor control component are extremely important considerations and are actually fully integrated with your HVAC system, right, or with your climate control system. They have to be. Just speaking to biosecurity first, you're not generally producing anything dangerous to your plants inside of a controlled environment, right? Generally speaking, anything that is dangerous to your plants is infiltrating from the outside in one way or another. The sole exception to that being potentially mold if you're not managing your humidity, right? But certainly there are certain funguses that thrive on poorly managed humidity. That is one component to it. So managing the humidity is really vital to ensuring that those funguses, do not have a hospitable place to live. Managing the climate correctly is also extremely important to ensuring that your plant's natural defenses to anything that does make its way in are operating at their highest level, right? Your plant has some natural immune responses to certain pests or pathogens, and should something make its way in there, if your plant is not experiencing a perfect environment, well, then its ability to fight those things off is diminished. So those are the kind of obvious things that are directly related to managing temperature and humidity, but then you've got some kind of less obvious things. And that's primarily related to ventilation and filtration and sterilization. The better your SOPs or your standard operating procedures are for your personnel, the better off you are as far as not bringing things into the building. Same goes for your HVAC system. Generally speaking, HVAC has a natural ventilation component, right? Particularly when folks want to minimize energy use, they may use some what's called airside economization, where you bring in outside air for the purposes of managing the climate. That's actually counterproductive in most cultivation operations. For one thing, it makes it a little bit more difficult to manage humidity very precisely because the ambient conditions are constantly changing. And secondarily to that, we're usually using CO2 or adding CO2 to our cultivation environments to ensure that we're able to boost yields. And if we're ventilating, air in is air out, right? Every CFM of air I add to the room is a CFM of air I have to reject. So, obviously it's best to keep that CO2 in the facility where my plants can turn it into oxygen as opposed to pushing it out into the environment. And then lastly is the contamination component of bringing air in from outside. Various regions, as I'm sure you guys have experienced, will have various kind of natural plant pests, pathogens. That means viruses, that means bugs, that means funguses. So anything I do bring into the building, I want to ensure that I am filtering and sterilizing very accurately and adequately, and that's an important component of the HVAC design in the building. So those are all very important considerations as it relates to the HVAC design for biosecurity. Odor control is very similar, not as it relates to air coming into the building, but as it relates to air leaving the building. Again, a CFM of air coming in is a CFM of air that has to leave. So we want to ensure that any air leaving the building is very well filtered and is very well controlled. And that's really one of the things that I've always really liked about your approach, Chris, is ensuring isolation of all of these cultivation environments, ensuring that if you were to have an issue in one of your environments, that is not able to be distributed or spread to any of your other environments. And then the odor control component, everything is really well contained in individual areas, right? And we're not seeing a lot of odor pollution.
Well, you're absolutely right, and we treat these incoming pests, if you want to talk to them like that as if they're a virus, and some are. So, you know, for us, we're treating particulate. Particulate includes mold spore. It could have other biological, but more importantly, we're looking at bacteria and virus that can get into these environments. And one of the lessons, hard lessons learned for some of the largest producers on the planet is they were always go bigger or go home with regards to the largest open area for indoor grow. But all that meant is that whatever got into those environments now had a much larger population of plants to rip through. And often that would happen within hours. And by the time they figured it out, they were losing entire batches. And I was thinking of that one very large LP that was in Western Canada, in the province of British Columbia, I'll keep them nameless, where they lost 3 of their largest greenhouses and had to report a $40 million crop loss to their investors. And that's simply because they couldn't contain it once it got in. And so the challenge that we have in any complex working environment, and coming from GE myself, being able to manage on a 6 sigma level where you try to get down to 1.9 defects per every 3.4 defects, sorry, per million operations, is it's virtually impossible. You will have defect. Something will get in. And so the best thing you can do is control the size of the batch. And to do that, our habitats are managing no less than 32 plants, but depending on the crop, is not going to be very large. You can afford to lose a small habitat if and ever it gets back in. Now, with regards to where we are, definitely our experience, and you've seen this practically around all of your client locations, but here particularly, everything that wants to kill your plant already lives here in Panama, and we have it all. You know, whether it's insect, whether it's rodent, whether it is mold, fungus. There's a particular fungus here that on mushrooms, for example, will once it invades the feedstock for mushrooms, will wipe it out within about a day. And there's no coming back. And there's a powder mold that will do the same, in the particle size of the powder is well below what I would normally even expect to see for Stachybotrys or Aspergillus mold spore. And because of that, once it's in your system, it's almost impossible to get rid of. And so you have to treat these vectors, these contamination vectors, with absolute respect and put in good control systems for that. And so by compartmentalizing what we have, we've been able to limit risk. In worst case, you could take one of the habitat tents down and dispose of it and put in a brand new one rather than proceed to sterilize it and put it back into operation within an hour. So that's been our approach for sure. Now, Brandy, with regards to costs, you know, you have some very good metrics in your mind, and you have great lectures, and I would refer to anyone that wants to learn more about HVAC in particular, in systems, control systems, for example, to go to the Surna website. They have videos there. They have a great resource center that also has papers and other materials that could help you along. But Brandy, in terms of cost, when we're talking about a facility that wants to go indoors, this isn't cheap in the sense that it's not outdoor air grow, right? We are in a controlled environment. And so we have to put in these systems. What normally are we looking at? What metrics would you typically use to cost a facility on a per square meter or per foot basis, provided, of course, that the warehouse or the building is relatively normal, not something unique?
That's a really good question, and I think that folks are generally unpleasantly surprised at really what their budget needs to look like. Folks once were unpleasantly surprised. I think that this industry has gone, you know, kind of mainstream, and folks are getting enough experience now that they have a little bit better idea of what to expect. But to do it right and to do it correctly, you know, anywhere from $200 to $325 per square foot of cultivation space is usually what we see. You know, these budgets ending at. We've seen it, you know, much higher, and we've seen it a little lower. And that's just the difference in investment in infrastructure and long-term profitability, investments in energy efficiencies, investments in biosecurity and controls, data collection. You know, you think of this as just like any other manufacturing operation. You want to dial in the operation, have a standard set of processes. We do A, B, C, D, E steps. We narrow down our harvest timelines to a very specific timeline, and we start the next one immediately after. And in order to do that accurately and adequately, we need to be constantly collecting data about our operation and constantly responding to that data to dial this into a manufacturing process. And so, in order to do that, that requires investment. Now, that's not to say that if you don't have one of those large budgets that you shouldn't try, right? But I would recommend starting on a smaller scale before trying to do the most square footage I can possibly do and kind of, doing it less than perfect.
Yeah, agreed. And that has been the absolute lesson for the last 7 to 8 years. As I said, we build it by building block, right? They're like Lego. You can turn these habitats on or off depending on their need. And we're only HVACing the habitat, not the warehouse. And depending on part of the world, of course, that can be done very well. Others may require some supplemental for the warehouse. But typically, for example, our project in Zimbabwe, South Africa, and most recently now setting up in New Zealand, where ambient outdoor temperature is relatively manageable. We're not managing the warehouse HVAC, we're just managing habitat. So that helps us keep our costs down. What's been interesting though, for any listener, we'll post some links below this podcast. There has been a lot of work done in then trying to better understand apples to apples, the costs of field cultivation versus greenhouse cultivation versus true indoor vertical cultivation on the cost per square meter of the overall operation, balancing that against the yields. And because the indoor is strictly controlled, not only do we see a higher repeatability of batches, but we often, if not always, see more batches produced because the environments are controlled and they're not wonky, right? I was very used to maybe only seeing one crop per year outdoors in Northern Canada, for example, maybe on a good year, two, maybe, but the yields were unpredictable until you actually got them in. They got hail flat in the last week, they got rained on while you're baling. Like there's all these, there were thrashing, there's all this that could happen to you that's completely out of your control. Mother Nature is a big B, right? But in this case, being able to control your batches, know that you can meet your delivery schedules, have perpetual harvest. In our case, having every habitat timed effectively if you want to harvest them every hour on the hour in a facility of 1,365 of these units. That is a very good economy of cost and scalability. So we'll be providing more information on that in future. But we'll leave it to say, for those that are under pressure to secure supply chain, when we take out the cost of transport, we take out the cost of wastage that we're experiencing right now due to delay in transport. We take out loss of batch due to perceived contamination. We saw in California, for example, that's been providing leafy greens up to Alberta and in British Columbia are banned now till the end of December because their lettuce came in with E. coli 0157. That's the Walkerton pathogen that either kills you or leaves you with renal kidney failure. So long story short, we are seeing a resurgence with regards to how can we do this repeatably, economically, practically. How can we make it easily scale? How can we make it safe and secure? Is going to be a very interesting future for both of us. So I'll ask you if you have any last comments, Brandy, for any of those individuals that are looking to get into urban cultivation, whether it's for cannabis or other athenogens. We're seeing a huge push now, and we're getting involved in projects for this to do psilocybin mushrooms or ayahuasca, and we'll go through the list, which is really kind of interesting to meet the pent-up demand for psychedelic drugs under medical prescription. But any last comments, Brandy, and then I'll sum us up. Go ahead.
Yeah, to your point about how much value there can be in controlled environment cultivation, and in in comparison to the expense of doing it, I'll point you to entire outdoor crops that have been completely destroyed in Washington, Oregon, and California this season because
That's
of.
right.
I'll point you to Alaska having very little produce for 10 days at a stretch when tankers are out of commission in the ocean because they're moving product from California to Alaska. I will point you to the derecho in Iowa, recently, which millions of acres of crops. So there's certainly a sustainability component as far as security in the food supply associated with cultivating in controlled environments. There are other, and I don't know how much time we have, Chris, so give me a heads up if I'm using too much time, but there are also very tangible benefits associated with water resources and pollution. How much water we use in traditional agriculture, and where that water goes and where it ends up. In the Everglades, we have to constantly, in Florida, right? We're constantly monitoring the Everglades for fertilizer run, and what it's doing there. And in controlled environments, from a water resource standpoint, you can be at very near a net zero water usage if you recollect all of that condensation and reuse it. Obviously, we have the energy use associated with it, but the fact of the matter is, energy is really the only thing we can produce for free. We can't make water, right? And so if we continue as companies like Surna and as companies like you guys are doing, if we continue to focus on making these things as energy efficient as possible, they're actually more resource efficient than traditional farming and result in much higher security of
Well, you're absolutely right, Brandy, and we are aeroponic, not hydro, not aqua, and we are using a fraction of their water. And if in terms of measuring us against a traditional greenhouse, for example, it uses what's called a flood table, or what we would call a Dutch bucket system, which is a bunch of plants in a bucket of substrate, whether that's a compost or soil or a cocoa coir chopped up coconut husk that's forever being dripped water. We use a fraction of that. And by adding nutrients directly to the water, pure nutrients, phosphorus, nitrogen, potassium, magnesium, and on, there's no risk of contam. We're not getting an outside vector coming in. We don't need a big mountain of this outside the facility that gets contaminated waiting to get into production. We don't have that problem. And once the water is returned in our lines, we can filter it out and return it back into the system as a closed loop. So in terms of water use, you're absolutely right. It's a fraction. In the project that we have in South Africa, water conservation is mandatory in parts of the country, like near Cape Town. And in fact, if anyone has stayed there in the last year, depending on the hotel, they actually put a water meter on your shower and restrict the use of your shower because water is so constrained. So being able to demonstrate that we can grow food for a fraction of the water use, as you said, and using LEDs and other controllers that significantly reduce the load on the power grid for those countries that don't have a lot of access to resources, whether that's hydro, whether it's geothermal, even projects that may not have the benefit of solar, we can assist. So fantastic. So Brandy, I think to kind of roll it up, I would say this: the future is bright for indoor cultivation. Those cities, even like Taipei, we actually have a reach out to one of our members, Rob Laurie, will be presenting in Bangkok. Bangkok is looking to set up indoor cultivation for food security for Thailand. If you can imagine that, Thailand, with all the land that it has, is focusing on indoor cultivation. So that for us may be the legacy of this recent pandemic. We've seen a lot of social change. The industry was already accelerating over the last 3-4 years, as we saw many of these multi-projects raise, as I say, hundreds of millions for technology development. But if there was one thing I would impart, is that the cannabis sector paved the way. We learned so much over the last 8 years, how to take a batch that may only do 3 crops a year to 5.2 crops a year, how we could do it for a fraction of the water in the power, and how we can make a repeatable batch in a plant that just doesn't want to repeat itself batch over batch, right? So it's been a technology transfer that I think that the world will have a good benefit of. So my name is Chris Bolton. I'm the CEO and founder of TheraCann, of which Sprout AI is a fully owned subsidiary. Come join us on our sites, and we can share a lot of information. We will be posting our link, of course, directly to Surna. They have a wealth of information there, and if there's one thing I can say from personal experience over the last 2.5 years, is Surna is best in class with regards to technology, and certainly with regards to the complexity of indoor harvest and grow. Randy, thank you so much for this Sunday morning coffee. Look forward to chatting with you again in future.
Thank you so much for having me, Chris. I really like what you guys are doing, and appreciate your time.
Fantastic. Enjoy your Sunday.
Bye, guys.